morning, finishing up polynomials and rational functions, looking at variation. Broadly, two types of variation. First is known as direct variation. X and y are related by an equation of the form y equals k x to the n. We say that the relationship is direct variation and that y varies directly with the nth power of x. We also write this as y is proportional to x to the n. K would be called the constant of proportionality. Gotcha. And then we also have inverse variation. X and y related by an equation of the form y equals k over x to the n. We say that y varies inversely with the nth power of x. Again, you can also write this as y is proportional to 1 over x to the n, or y is inversely proportional to x to the n. Again, k would be a constant of proportionality. And could be more than one variable that y is proportional to. In either case, and you can mix them. Right? So you could have it directly proportional to a power of x and inversely proportional to a power of z, for instance. Here we're told s varies directly as the square of x, and that s is equal to 5 when x is equal to 4. We're asked to find s when x is equal to 20. This is what it means for s to vary directly as the square of x. We just have to find that constant of proportionality. S equals 5 when x is 4. Means k is 5 over 16.
So you just plug them into the equation from before.
To find the constant of proportionality. That would be the model for this direct variation. S is 5/16 of x squared. Now we can find what S is when x is 20. And to make life a little bit easier. 20 is 4 times 5. And 20 squared would be 4 squared times 5 squared. 16 in the denominator. Cancels out. You're left with 5 cubed. And 5 times 5 squared. 5 cubed is 125. Y varies directly to the cubed root of x. We also know that y is 12 when x is 64. Cube root of 64. You shouldn't need a calculator. 4. It's 4. K is 3. Y would be 3 times the cube root of x. Now, what is y when x is 1/8? Cube root of an eighth is what? It's cube root of 1. It's cube root of 8. Cube root of 1/8 times 3. 3 halves.
So would it be wrong if I put 1.5?
No, but by convention, we'll keep it as improper fractions. But you You would be wrong if you said a third was 0.33. Because it's not. I is inversely proportional to the square of t. I is 100 when t is 15. So what is 15 squared? $225 times 100, you shouldn't need a calculator.
22,500.
And 22500, which is just 22,500. There's I. Now, what is I when t is 12?
Can I use a calculator for that?
Shouldn't need to. $625 over 4. And 22,500, break it down to prime factorization. You know it's 225 times 100, right? 100 is 10 squared, which is 5 squared times 2 squared. 225 is 15 squared, which is 3 squared times 5 squared. You know that. Over 144, you know is 12 squared, which is 3 squared times 4 squared, which is 2 to the 4th. I can simplify from there. It's 5 to the 4th over 2 squared. 5 to the 4th is 625, 2 squared is 4. So you get 625 to the 4th without the use of the calculator. U varies inversely as the cube root of x. U is 56 when x is -8. Cube root of -8 is what?
2i. Negative 2.
It's just -2.
Why wouldn't it be 2i?
Cube root.
Oh, okay.
What's K? Close. You have the right magnitude.
-112.
There's you.
And that's when we just stop there.
What's cube root of 1,000? Yeah, and you don't need a calculator for that. Powers of 10 you should know, right? -56/5 or -11.2. Z varies jointly as x end of y. Z would be k times x times y. K is a constant of proportionality. Z is 3, and x is 4, y is 6. Four times 6. Better know that one. So what's K? What is it?
72. 72. 3 times 24.
It's not 3 times 24 though, is it?
Divided by 24. 7. 6.
1/8. You did 24 over 3, not 3 over 24. Z is xy over 8. Write this.
Why are you like changing the format of it?
What do you mean?
Like it's not z equals kxy anymore.
Sure it is. K is an eighth, right?
Oh yeah.
1/8 times x times y, you can just multiply straight across. So it's the same thing. No, I don't want 4 and 6, I want 20 and 9. So z when x is 20 and y is 9. 20 times 9, which simplifies. And rule for 4 is if the last two digits are divisible by 4, then the whole number is divisible by 4. 80 is divisible by 4. So 180 is divisible by 4. So it's 180 divided by 4. It's 45. Over 2. P varies jointly as the square of x and the fourth root of y. That's what? K times x squared times fourth root of y, or y to the 1/4. B is 24 when x is 12, and y is 81. What is 12 squared? What is the fourth root of 81? It's 3, right? 24 divided by 3.
Divided by 3.
8 divided by 144. Well, 144 is 12 squared. 3 squared times 4 squared, 2 to the 4th times 3 squared. 8's 2 cubed, right? So you get 1 over 2 times 3 squared. Which is 18, 2 times 9. That's what P is. So now P, when X is 1200 and Y is 116. $1,200 squared, you don't need a calculator. $12 squared. 100 squared. You said 1,000? 100 squared. It's 10,000. 144 times 10,000 is what? 144 with 4 zeros after it. That's what? 1,440,000. Fourth root of 116. The fourth root of 16. It's 2. So it's the fourth root of 16. Half. This one's fun. So you could do half of 1,440,000.
Or you could just do a half of 144.
And then we'll follow by 4 zeros.
Yeah.
Could do that. So it's half 144. Now 72,000 divided by 18.
That's less than 2,000.
Hmm?
You wanted someone with 2,000. You said someone with 2,000.
Oh, 720,000.
Or 40,000.
So 720,000 over 18. Here's P.
So for these two problems, you're going to have 2 different answers? Or just one answer?
Just one answer. Because you have to find the constant proportionality first. Because it's very unlikely you get a problem that looks like this. Probably more along the lines of a word problem. Hooke's law. Hooke's law says the force needed to stretch a spring x units beyond its natural length is directly proportional to x. It's not actually what Hooke's law states. The actual statement of Hooke's law is when a spring is either stretched or compressed beyond its natural length, it exerts a restoring force that is proportional to the stretch or compression in the opposite direction. That is actual Hooke's law statement, which can be reworded to this.
Isn't that just elastic? Isn't that like the elastic thing?
Elasticity is different than springs.
But when I think of upstairs.
If you're talking about rubber band, that would still be governed by, actually would it be governed by Hooke's law?
Now, like when if a car went a boom and they went apart.
No, that's not Hooke's law. You're talking about elastic versus inelastic collisions. That is different. Yeah, collisions are not governed by Hooke's law. Actually, a bit more complicated. So what this says, force is proportional to x. Just means that force is some constant times x. In this case, that k is called the spring constant. And it's just a constant of proportionality, but for springs we call it the spring constant. Every spring has its own unique constant. You unfortunately can't discover what that constant is without experimentation. But they did the experiment for us. So a certain spring is stretched from its natural length by a force of 6 pounds.
Those be 6 equals.
Hold on. Something's missing. Somehow, how much it was being stretched was not included. Stretched a ½ inch from its natural length by a force of 6 pounds. So it took 6 pounds to stretch the spring a ½ inch from natural length.
So F would be 6.
Find the force necessary to stretch the spring 2.25 inches. And so F is 6 pounds.
And K is 0.5.
K is not 0.5.
There's half inch.
X is 0.5. I'm going to use decimals here because they actually use decimals in the problem.
So 3.
Six divided by a half. Use it 6 times a half. 6 divided by a half.
And what did I do?
You did 6 times a half. You want 6 divided by a half.
12
It's 12. What are the units?
inches. Inches per pound. Pounds per inch.
But we don't typically write that. We won't say pound per inch because this is not a rate of change.
Pounds per second.
It's not a rate of change. So we won't say per.
Pound squared.
It's the pound inverse inch. Right. In physics, we say per exclusively for rates of change. Right. So like velocity, meters per second. This is just a constant. It's not a rate of change, so we wouldn't say per inch. Right, so the force is 0.5 times x. And again, we typically don't include the units in the actual equation. Find the force necessary to stretch the spring 2.25 inches.
So it would be 12 equals
0.5 times 2.25. This is we're thinking in terms of fractions would be helpful. 2.25 is 9/4. Wait. I'm sorry, that's not 0.5. You're right, it's 12. Why did I write down 0.5?
so it would be 12, right?
So it's 12 times 2.25, which again, may still probably easier to think of it in terms of fractions. 12 over 4 is 3, right? What's 3 times 9? It's 3 times 9.
27.
And your units?
Pounds inverse inch minus.
Just pound. Inverse inch times inch cancels out, which makes sense. Units for force in the empirical system is the pound. So take 27 pounds of force to stretch the spring 2.25 inches. It's actually a pretty strong spring. Ohm's law states the current I in a directed current circuit varies inversely as the resistance R. If a resistance of 12 ohms produces a current of 3.5 amps, find the current when the resistance is 2.4 ohms. So Ohm's law is saying that the current is proportional to the inverse of resistance. And so current is inversely proportional to resistance. And so current is K over R. I'm also fairly certain this is not the actual Ohm's law statement.
Yeah, that's because it's like, it's V, it's I times VR.
I think Ohm's law statement actually involves differential equations. It deals with rates of change. I'm fairly certain. It just solves to this. In a directed current circuit, so there's different types of circuits.
Yeah.
For a directed current circuit, it would solve to this. The one you're thinking of, I think also,
Like a DC circuit?
it has,
AC
you're probably thinking of inductance circuits. Circuits that have inductance as well. Inductance L.
Yeah. I mean,
Which is more realistic. Circuits is a pain. I did my time studying them, but I don't have to look at them again. Resistance of 12 ohms produces a current of 3.5 amps. What is K? What's 30? What's 3.5 times 12? Again, you don't need a calculator. What's 3 times 12?
46 or 36.
And then half of 12,
So,
then add them, that's where you get 42. 42 what?
ohm. 42. Oh, wait. So, wait, we just did 12 times that. 12 ohms times 3.5 amps.
So what's the units?
Realistically, it'd be voltage, but in this instance,
Is ohm times amp voltage?
yeah, current times resistance to the voltage in a circuit. That's what Ohm's law states. Voltage is current times resistance. Ohm's law is like a basic engineering. I think. Realistically, it would be voltage.
Yeah, amps times ohms is voltage.
Yeah, I'm an
But we're not using voltage. voltage. Well, I guess you could. K, this constant proportionality would represent the voltage of the circuit, which is a constant.
Especially in a DC circuit.
I've always having to rank the bars over voltage in my E&M and circuits classes to distinguish it from a variable V.
I was right. I remember.
Yeah, sadly, when you get to advanced physics, you'll get V's a lot.
Yeah,
And you want to distinguish between the variable V and the voltage V, so we always just drew that, and it kind of stuck with me. I think in basic circuit analysis, you're fine. When you get to the more advanced stuff, you want to distinguish. All right, so I is 42 over R. Right, so I of 2.4 ohms. I'm actually going to write it this way.
Okay, that's fine.
So 42 divided by 2.4. 2.4. Point 4 is 2/5. Twelve over 5 would be 2.4. 12/5. So 42 divided by 12/5 is the same as 42 times 5/12. And this is just going to be amps, right?
Yeah.
42 divided by 12. 21 over 6. And then 21 is divisible by 3. So 7 over 2. And then what's 7 times 5? 35. 35 half amps. Keeping it as a decimal because that's how the problem gave it to us. 35 halves is 17 and a half. Seventeen and a half amps. Pressure. In this case, we're looking at pressure of wind. So pressure of wind on a wall varies jointly as the area of the wall and the square of the velocity of the wind. So that should actually be surface area of the wall. Right, you're not going to have a two-dimensional wall. You're going to have a three-dimensional wall. Because you also have thickness. But we'll ignore that. So pressure would be KAV squared. We need to find that constant proportionality, K. We're told 100 pounds of pressure when surface area is 80 square feet. And velocity is 40 miles per hour. So that's two typos from the source. Because that shouldn't be velocity either, that should be speed.
Wait, so can you write like the original? Oh. So that's the equation for pressure.
For this problem. And this is pressure of wind. Remember, there's different types of pressure. You also have water pressure, which is different. What is 40 squared? That should be an easy one. You're off by a magnitude of 10, 1600. Forgot the square root of 10. And that's going to be foot squared, mile per hour squared. And square foot times square mile per hour. What is 80 times 1600? Well, let's make it easier. 8 is 2 cubed, 16 is 2 to the 4th. So 2 cubed times 2 to the 4th is 2 to the 7th, which is what? 128? Yeah, 128. 2 to the 5th is 32. But you also had a 10 and 100.
So right now we're doing 80 times 1600 and then 100 divided by that.
So what I said was 128 and then 3 zeros. I'm not going to write out the units because of them. And now 100 divided by that. That's easy. One over 1280. And the units. pound. It's not a minus, that's a hyphen. Pound times the inverse square of the foot mile per hour.
Pound times.
Again, physics, most of the sciences, when you're doing multiplication of units, you usually separate them with a hyphen.
Just like inverse mile per hour.
Inverse square.
So how would you say that whole thing again?
The inverse square foot mile per hour. There's wind pressure. AB squared over 1280. Find pressure when the surface area is 120 square feet and the wind speed is 50 miles per hour. Over 1280. Square.
If the miles per hour and the feet are going to cancel out, then what is the unit of pressure?
They told you what the unit pressure is. Pressure is a force. So units pound. So that should all be to the -1 in the denominator. What would be easier?
120 times 50.
Oh, that's squared though, that's right. So cancel out the 10s in the 12 and the 1280. 120 and 1280, so you're going to have 12 over 128. That'll probably be easier. 50 squared. 5 squared is 25. 10 squared is 100, so 50 squared is 2500. And we're going to be left with pounds when we do the unit analysis. (12 over 128), that can be simplified. 28 is divisible by 4, so 128 is divisible by 4. Three times 2500 is 7500. So what is 128 divided by 4? What is it?
32.
can be simplified more. At the very least, 4. You can divide by 4 at the very least. 32 divided by 4 is 8, so 7,500 divided by 4.
You're saying that simplified is 1,875 over 8.
One 1,875 pounds is the pressure. Weight of an object above the surface of the earth varies inversely as the square of the distance of the object from the center of the earth. Weight is inversely proportional to the square of the distance from the center of the earth. Quickest way to lose weight: increase your altitude. Higher your altitude, less you weigh. Actually, a quicker way. Problem is the end doesn't end well. Just go in an elevator, cut the cords, go into free fall. Now you're weightless.
It's the same as if you were in space. You have no gravity.
That's actually not true. There's still gravity.
Like if you were going to split, if you were going to go
There's still force of gravity. You always have gravity acting on you, believe it or not. You can't go anywhere in the universe and be unaffected by gravity. The reason you think there's no gravity is that once you get to a certain point, you start orbiting, you're actually in free fall. Orbit is just free fall.
So that would be the same as kind of cords on the other.
With a less impactful ending. Pun totally intended. Because you're weightless for however long and then the elevator hits the ground and you go splat. Another thing to give you comfort, it's not the fall that kills you. It's the sudden stop at the end. That's what's deadly. The fall itself isn't. So weight is K over D squared. Now here I actually know what K is, because this is governed by Newton's universal law of gravity.
So would that be enough weight?
Hmm?
Wait, so there would be gravity involved in it? So
Weight is gravity.
Gravity is 9.
Weight is the force of gravity that is exerted on your body. That's what your weight is. So that's what a scale measures. How much force is the earth pulling you down with? That's your weight. Which is why I don't like the metric system where they put weights in kilograms. So that's actually not correct. Kilogram is a unit of mass, not weight. This is Newton's law of gravity. GMM over r squared. G is the universal gravitational constant, which is actually really small. Big M is the mass of the larger object, little m is the mass of the smaller object, and r is the distance between them.
So G would be 9.8?
No.
But that would
That's the acceleration due to gravity on Earth. That's little g. Big G is the universal gravitational constant. I forget the exact number, I know it's times 10 to the minus 11. So it's a very small constant. It's like 2 point something or 8 point something times 10 to the minus 11.
So you'd have to use that.
No, we're going to use the information we're given to determine what GMN is. Right, because that's going to be K for this problem. Astronaut weighs 120 pounds at the surface of the Earth to the nearest pound. Or how much to the nearest pound would he weigh in a satellite 400 miles above the Earth? That was weird. Okay. Use 4,000 miles as the radius of the Earth.
So 400 squared.
So 120 pounds is equal to K over distance squared. We're actually making an assumption here. We're assuming that when they say the astronaut's on the surface of the Earth, he's at sea level. Right, that's an altitude of 0. Then you can use the 4,000 as the radius. That'd be your distance. Which, of course, it actually really doesn't matter if he does have a certain altitude. Even if you're on top of a mountain, that altitude is going to be so insignificant when you square it. That's really not going to change much. What is 4,000 squared?
1,600,000. 16.
Should be 16 million, right?
16 million, yes.
And 16 followed by 6 zeros. Oh boy, K is going to be really large.
We can just do like
16 million times 120.
100.
So just do 12 times 16 and follow that by 7 zeros.
192. So 192 times 10 to the. Couldn't we just do that and make it simpler or no?
And inverse square miles. I'll go even further than what you're doing.
So just 7, 8, 9. So 1.92 times 9 to the 10 to the 9.
1.92 billion. Inverse square miles. So this is your weight. Or at least the weight for this astronaut. Of course, now I'm thinking about it. That is either a very short astronaut or a very skinny one who should not be going to space.
So for B, now we do 400.
Yep, so not 400. He's 400 miles above the surface.
4,000. Okay. Oh, so it's going to be.
What was the distance at the surface?
4,000.
You're now 400 miles above the surface. So what's your new distance?
4,000 squared. 4,000.
It's 4,400. Right, if the surface is 4,000 and you're now 400 above that, it'd be 4,000 plus the additional 400, right? 4,400. .92 times 10 to the 9th. That should not be in your square mile. That should be pound in your square mile. .92 times 10 to the 9th. $4,400 squared. So do it this way: 4.4 times 10 to the 3rd squared. So what's 4.4 squared?
$19.36.
19.36 times 10 to the 6th power, which is 1.936 times 10 to the 7th. Square miles. .92 divided by 1.936, and it'll be times 10 to the 9 minus 7, which is squared. This is going to be just slightly over 100 pounds. Right, so what's 1.92 divided by 1.936? Oh, I'm sorry, be slightly under 100 pounds.
9.95 times 10 to the 15.
Not 15.
That's including, that's 1.92 times 10 to the 9.
Wait, I'm sorry, it'd be 0.9.
16?
9,
16?
5 times 10 squared. It's 10 to the 9th divided by 10 to the 7th.
Oh, so you should track.
It's 9 minus 7, too. And that's in pounds, so we'll say about 99 pounds. Right, 99 or 100 pounds, depending on how you want to round it.
And that's just you moving the decimal point over and taking out the.
Because it said to the nearest pound. Like 1.92 divided by 1.936 is not exactly 0.995. So there are two corrections I needed here. Where's the other one? It was Hooke's law, wasn't it? Half inch. This one. I hate this law. Volume V of a given mass of gas varies directly as the temperature T and inversely as the pressure P. This is the ideal gas law. Vp equals, what is it, kmt? K is a constant, a gas constant. M is number of moles. And T is temperature.
So in this instance,
We don't have to worry about the Kn because it's all built into that
okay.
constant of proportionality here, yes. Right, and the K in the actual law is a constant, which means only N is going to vary. Only the number of moles will then affect what that constant is. Gas has a volume of 16 cubic inches. When the temperature is 320 Kelvin and the pressure is 300 pounds per square inch. .320 divided by 300 is 32 over 30, 16 over 15. Kelvin square inch inverse pound. Oh, that's nice. 16 divided by 15 sixteenths. Or 16 fifteenths. It's 16 times 15 sixteenths, which is just 15. Inch pound inverse Kelvin. That would be the volume for this specific gas. Of course, there's no such thing as an ideal gas. We want volume when temperature is 350 Kelvin and pressure is 280 pounds per square inch. I am not going to write out units for this. We know what the volume unit should be, so if you do the unit analysis, you should get cubic inches. 15 times pressure was, not pressure, sorry, temperature 350 all over the pressure of 280. 15 times 35 all over 28, which is 15 times 5 divided by 40. What's 15 times 5? 75. 75 quarters cubic inches. Some trivia. This problem actually really irks me.
This one?
What is the SI unit for temperature? Do you know what that is?
Celsius? Degrees?
Well, degrees there's
Hours?
2.
The SI unit is?
What's the SI unit for temperature? It's not Celsius. It's not centigrade. And it's technically degrees Celsius, but it's not that. It's the Kelvin, which is what they gave. So do you see the problem? Kelvin is the SI for temperature. See what the problem is? They gave volume in cubic inches, which is nowhere near SI. That was SI, it should be cubic meters. Which means pressure is also not in SI. It's empirical. That should be Newton per square meter if it was SI. So they're mixing SI with empirical, which is a huge problem. That's a no-no.
Newton is a force.
Newton is force. And so that's why this irks me. They're using both SI and empirical, which is a huge no-no. Now, the reason why it's not degrees Celsius is SI. What does 0 degrees Celsius represent?
So Celsius zero, not a 0 Celsius.
What's 0 degrees Celsius?
I don't even know what it is.
Just freezing point of water.
Freezing point of water, can you get colder?
Yes.
What does 0 Kelvin represent?
Absolute 0.
That is the coldest it can be. That's why Kelvin is the SI. Because when you hit 0 Kelvin, that means absolutely no heat.
And then 0 Celsius?
Whereas 0 degrees Celsius just means it's the freezing point of water. You can get a lot colder. In fact, it goes down to negative 273 as absolute 0. And also, cold is not a thing. Cold doesn't exist.
It's hot. It's heat.
When you say cold, you mean lack of heat. Heat is the thing in physics, not cold. So 0 Kelvin means 0 heat. There is no heat. Another fun thing, water's not wet. Wet is not a characteristic in physics. It's a feeling. Water itself is not wet. You get wet in water because that's how you feel. But water itself is not wet. So a little early today. Second quiz is now up. Oh, no, not yet. It won't be up until 11:50. And so it'll be up in like 17 minutes. Now that will be due before the start of class on Wednesday. And that covers weeks 4 through 6. Second project is also due Wednesday, so maybe use this time to finish that up. Wednesday, we start the next topic, the next unit. So we look at exponential functions.